Welcome back guys. In this video tutorial I am going to set up a new sensor that is H3LIS331DL. Let's move on to the website controleverything.com and here search on for this sensor so that we can have an overall view for this sensor, which says that H3LIS331DL is a 3-axis linear accelerometer. It's an I2C mini module, as you can see, and it has a dynamically selectable scale or full scale range is plus minus 100G, 200G and 400G, and it's a 16-bit data output and the result will be there. You can also purchase this sensor from this very site. For today I will be interfacing the sensor H3LIS331DL with a particle photon, and a code is required. So go to resource tab and here comes the particle code sample we are looking forward. Now you can download the code as zip file from this very link. That's correct. Also you can have the code from GitHub repository that is called Control Everything Community. Now let's have a look over the hardware we need to set up this device, make some connections and proceed. This is our sensor we are looking at is H3LIS331DL, and this here is a particle photon. Now to make a connection among the sensor and the particle photon, this here is an I2C shield we are looking at, and this is available on the website controleverything.com. Now why we use this I2C shield is to make connections with other I2C devices or rather easy job. So gently press it over the particle photon over the I2C shield and make the connection. Now to make a connection among the sensor and the I2C shield, we need a connecting cable just like this and make the connection. While making the connection, make sure that the ground terminal of the sensor should be connected to the brown wire of the cable from one end, and on the other hand this is the same condition we have to apply for the I2C shield, and we are done. Now the last part is to power up the particle photon, and a micro USB cable comes into the picture. Now gently insert it over the power jack and we can light it up. Now we are done with the connections part. What we require is a particle code so that we can interface our sensor along with the particle photon with that. Let's have a look over that. So what we require is a particle code so that we can interface the sensor with the particle photon. So for that, log into github.com, and here we have to search for the repository that is Control Everything Community, which you are able to see on my screen. That's right, it's there. And here we have to search for the sensor that is H3LIS331DL. Yeah, here it comes as you can see on my screen, and this is the particle code we are looking forward to explore. But before that, let's have a look over the instructions we need to follow for pursuing this code. We have to log into our particle photon and set up the device, and the steps are being provided on this very link. Let's have the link so that we can have the clarification regarding every procedure. As you can see, this is the procedure we have to follow to connect our particle photon, set up the photon here. Yeah, note it down. Next we have to download or git pull the code, and we have to copy the code on the online ID, and build.particle is the online ID where we have to save the code, paste it, and everything has to be done here. Yeah, just like that. As you can see, it's coming here. We have to paste the code and we can save it from here. Now the last part is to verify and flash the code on the particle photon, and the code output will be displayed on the dashboard link. And here comes the dashboard link. As you can see, the output will be displayed in the form of acceleration, as you can see. Now as you can see, it will output here. So note it down carefully all the instructions, and now proceed to the working of this code as we can explain. First of all, in the code we have included application.h and spark wiring I2C.h header files, and we have defined the address of the sensor, that is 0x18. We have initialized the acceleration variables, as you can see, and we have set the variables also here in the void setup function. Now we have initialized I2C communication as master along with serial communication and the baud rate equal to 9600. Now comes the writing part, where we have selected control register 1 having address 0x20, and the command we have sent here is to enable XYZ axis power on mode along with data output rate equal to 50 Hz, and it comprises 0x27. Next we have to select the control register 4 having address 0x23, and the command we are going to send here is to set the full scale plus minus 100G and continuous update, and this is 0x00. Now we are done with the writing part. What do we require is to read data. So for while loop function, we have a for loop which will read 6 bytes of data, as you can see. Now we are selecting the data register 40 plus I. It's a decimal equivalent, and we are requesting and reading 6 bytes of data, as you can see. For the acceleration data for 3 perpendicular axes, that's x, y and z axis. After that, we are converting the data we have just received, and we are following the norms given in the data sheet of the sensor H3LIS331DL. At the very end of our code, we have the output data on the dashboard, as you can see, in the form of acceleration for x, y and z axis. So this is how generalized code for the sensor H3LIS331DL. Now what do we require to show the working? Let's have a look over that also. Now coming to the working part, which is very interesting in itself, we have to copy this entire particle code for this sensor and open up the link we have discussed earlier in this video, that's the build.particle.io link. And here we have to create a new file, save the code we have just copied, H3LIS331DL is the name of the sensor. Yeah, that's correct. And here paste the code. Now here save the firmware, verify and compile the code. As you can see on my screen, it's good to go. Now we have to check for the flash. Now while flashing, we have to check for the magenta flash, which confirms that code is good to go, and we can have our output data to be displayed on the dashboard. Yeah, that's good to see that we have the magenta flash on the particle photon, and you can see the successful notification of the flash. Yeah, here it is. Now we have to check for the dashboard so that we can see the output details, output data, and here we go. We can have the acceleration in all the 3 perpendicular axes in x, y and z axis. As you can see, the values are almost stable because there is no motion in the sensor, but when I try to move the sensor, you can see and the changes in the values regarding the acceleration in x, y and z axis. Yeah, that's correct. As you can notice, the changes are there visible on the screen, the sensor. Yeah, that's correct. Now this is how the way the sensor works along with this particle code. Now what do we require is to see the applications, the benefits of this particular sensor, that is H3LIS331DL. The H3LIS331DL is a low power, high performance 3-axis linear accelerometer belonging to the nano family with digital I2C SPI serial interface standard output. Now the device features ultra low power operational modes that allow advanced power saving and smart sleep to wake up functions. The sensor has dynamically user selectable full scale of plus minus 100G, plus minus 200G, plus minus 400G, and it is capable of measuring accelerations with output data rate from 0.5 Hz to 1 kHz. Now it's used in wide range of applications such as shock detection, impact recognition and logging, and concussion detection. You can purchase the sensor H3LIS331DL from the website controleverything.com, and you can have the code from the resource tab, and after that you can download it as a zip file. Also you can have the code from github.com, and you can download it from the repository, that's Control Everything community. Now in the end, I hope you enjoyed this video, and if you have any queries, you can contact us on controleverything.com, and you can post your comments, your queries on community page. Also for the articles and blogs, you can reach us on instructables.com. And if you want to subscribe more video tutorials, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and have yourself a good one. Thanks a lot for watching.